Hvala. So the question is, should we trust science? Should we trust scientists? In Croatia and many other countries, people are getting some money to teach the general society science. And there is this general notion that new tricks are really hard to teach an old dog. So we are teaching really puppies. And I will tell you what do I teach kids when we are doing this science popularization. So we begin, this thing is here. So kids love experiments. I hope you love it as well. And you have these pieces of paper, and please arrange them like this, arm length roughly. You will close your right eye, and with your left eye, look at this black disc. So roughly arm length. Do you see it? There is an interesting phenomenon that will happen when you do it. Okay? So I should walk away. Have you seen it? Yeah. So you do it like this. Okay, now you see it. So you close your right eye. With your left eye, observe there is disc and there is no cross, right? That is not interesting phenomenon. We know exactly why this happens. You have octopus eye here, and it evolved in such a way that these cells, light-sensitive cells, have these neural things here. Neurons are going outside of the eye to the optic nerve. Human eye, on the other hand, evolved completely independently. And if you believe in intelligent design, that you will have to realize that this is not really intelligent design. Because these nerves are going into the eye, and they have to get somewhere. And on this place here, we don't have these light-sensitive cells. And this place here is what we call blind spot. This is not interesting phenomenon. Interesting phenomenon is, what do you see on the place of a black cross? If there is no signal there, because there are no cells that can detect it, you should see a dark region, right? No light, it's dark. What do you see? You see white paper, right? So your brain hallucinates. Okay? You see something that is not there. When we talk about artificial intelligence, one of these really important things to understand is that artificial intelligence hallucinates. It's a feature of intelligence to hallucinate. Now you learned it. The cells that detect light, you know that we have two kinds, right? We have rods and cones. And kids usually don't know which are which. So I will show you how I teach them. Now you know. Okay? The main story tonight is the sea. The first thing that you see when you see the sea is its color. And maybe one of the first questions that children ask us as parents or older brothers or something is, why is the sea blue? Okay, so this is what I ask kids when I talk with them about science. Do you know what children usually say? Can you imagine a simple answer to this eternal question? Well, it's blue because it reflects the sky. And they're right. I mean, you see, you can even see the reflection of the clouds. But you feel somehow that this is cheating, right? It's cheating because we didn't explain why the sky is blue. And when we talk about why the sky is blue, this is me producing strange sounds. When we talk about why the sky is blue, usually we quite immediately realize that it's probably something related to the sun. When there is no sun in the sky, it's dark. When it's sun there, it's blue. So it's something related to light. Okay, now question is, what is light? Well, I can tell you quite easily what is light. Light is the energy. I have a prop here. Do you know what is energy? Definition from physics, you remember it. Its ability to do the damage. It's true definition. Check it out. But what is light? It's energy. So what kind of energy? And the particular kind of energy is really interdancing of electric and magnetic field. Okay, so I'm talking to the 8-years old, and I'm talking about fields. It's really complicated. And then I show them another experiment they can do at home. You have a foil like this, and if you rub it with some paper towel, hopefully you will see something like this. Okay? So when I rub it, it gets excess of electric charge, in particular negative electric charge, electrons. And these electrons surround this foil produce field. If you love Star Wars, you will call it force. It's not wrong. And this field really produces this attraction. Now, there is another interesting or crazy, if you like, phenomenon. Why this charged foil attracts papers which are obviously not charged. And they do not attract each other. They're neutral. And there is a guy on my t-shirt, Richard Feynman. This is not really going that well. And this guy said, he's a famous physicist, Nobel laureate, and he said once that the most important thing that we learned about the universe is that all matter consists of atoms. So, and these atoms consist of negatively charged electron cloud and positively charged nucleus. So when something which is negatively charged, like this foil, comes close to anything which is matter, it pushes these electrons slightly and attracts slightly the nucleus. And then you get something that has two poles, plus and minus. Things with two poles we call dipole. You're very familiar with dipoles. Can you imagine what's inside? Can you now? Okay, so the most famous dipole that you have seen is magnet. And so what happens when light, which is a dance of magnetic and electric field, enters the atmosphere? It comes to the matter. Matter are atoms in the atmosphere. And this dance looks something like this. Okay. So what happens when this field comes to an atom? It becomes a dipole. It's like this. and it goes back and forth. And what this dipole produces when it dances? It produces electromagnetic field, the light. And what will be the color of this light? It will have the frequency of the light that came from sun. So if it's a blue light, it will dance fast and produce blue light. If it's red light, it will dance slow, okay, and produce red light. How much light will be produced? And this is the crucial point here. If you just move dipole like this, it doesn't produce light. It doesn't produce electromagnetic waves. It has to accelerate, go back and forth. And this amount of light that is produced is proportional to acceleration. You remember acceleration from the school? When I talk to 8 years old, I have a different story. But for 12 or 13 years old, I will tell them exactly what I will tell you now. You remember acceleration. It's meter over second squared, right? Okay, so this 1 over second squared will give you how many times something will happen in a second, in some given time. It's frequency, right? So we have a frequency squared. This is amount of light that we produce. What is the energy, intensity of this light? It's the same amount squared. So what we got here is that this amount of energy that is taken from the original light from the sun and somehow spread around, proportional to the frequency squared. And what that means, if you take violet light, which is roughly 2 times faster, as a larger frequency than a red light, 2 squared is 4, squared one more time is 16. What that means? So the child knows. That means that the sky is really violet. Okay? You didn't know that, right? I have this thing here somewhere. This is the problem. You remember cones, right? These cones cannot see the light, the color, but they can feel that there is something blue. And if it's in this frequency here, we will have this, it's bright light. But if this frequency here, it's violet, you have to have huge amount of violet light for us to see something and say, yeah, this is violet. So this is not perfectly hallucination of our brain. It's more a defect of our eye. One more time. So the sky is really violet, but we don't see that well. We see the blue part. Okay? And now kids know that this is not the sea is really not blue, it's violet because sky is violet, sea is violet, and that's it. So this is why you need to know science. Thank you. We celebrate, we drink wine. Please go back, we're not done. We are grown-ups, so we drink wine and beer. It's not over. Of course you can have a question. So I'm telling you, we are celebrating, walking. We went to the seashore. We enjoy ourselves. And we remember the day before, we saw these reflectors, white reflectors put in the sea. And so it's night, we're walking there and see. Since I'm talking with kids, I would say, shoot, it's blue. Stupid reflectors are white. They're put in the sea, and the sea is blue. And you're thinking, okay, I must be crazy. I mean, it's so stupid. We wasted so much time to understand why the sky is blue, and now it's not blue, it's violet, and this should be violet, and it isn't. Can we use the same trick? Okay, let's try. This thing that happens in the sky with this frequency squared, which we call Rayleigh scattering, maybe it happens in the sea. And the answer, whichever physicist will tell you, is, of course, I mean, the sea is just different medium, but it must happen there. But could this be the result? Well, let's think about this. When you ask children to tell you what is the color of the sun, they will say, yellow. And we know it's not yellow, it's white. But what happens when the sun sets? It goes through more and more, this light goes through more and more atmosphere, and we lose more and more of this blue light. It scatters around. So what happens then? You remember this? So we are losing blue, and our red and green cones are excited, and we see it as yellow. And the same things happen if you have a golden ring or bracelet or something. It absorbs blue light. And what you see is yellow. And it's not yellow, it's white without blue, which is completely crazy, right? And this is what we see here. And when sun sets even further, the light passes more and more through the atmosphere. We lose green as well as blue, and we are left with red. What that means, if this is the reason, this is Rayleigh scattering, if this is the reason, then when we dive into the sea, we dive and first it's blue, and then we dive deeper, and then it's yellow. Is it yellow? Well, if it is, please go away from that place. Okay, it's not yellow. And if you go really, really deep, then it should be red, and it's not. Does this thing happen? Yes. Is it relevant for this phenomenon? No. Well, again, kids, shoot. What can be the explanation? And the explanation is completely crazy. And we cannot use this physics. We have to use quantum physics. And understand that atoms have these electrons, and they hold really, really tight to the nuclei. And you need to have ultraviolet light to kick them out. And ultraviolet light, we don't see. And on molecules, like water, you have 2 hydrogens and 1 oxygen, and they can absorb energy and dance. YMCA. You can dance. and they absorb which light? Infrared. Again, completely invisible for us. However, it's not just one color, it's spread. And the tail of this infrared enters the visible region. And water absorbs red light. And if we lose red from white, we get cyan. So you see, again, the same thing. So it's not blue, right? It's really cyan. And it's not cyan. It's white without red. So should we trust science? What we learned, the sky isn't blue. It's violet and blue and some other colors, but mostly violet. But our eyes don't see that very well. The sea isn't blue. It's cyan, but it's not even cyan. It's really white without red. But our eyes cannot distinguish between the two. And the reality we see is quite often just a hallucination of our brain. Our brain is naturally perfectly unaware of any of these things. And it has been like this for 3 million years of our evolution. So this is why you need science. We all need science. So we can hope that some parts of this science will sometimes in the future become, maybe it's not this classical electrodynamics, like this Rayleigh scattering, but it's quantum. But basically, it won't change that much. So we can hope that some parts of this science thing will change in the future, and most probably they will. But if we ignore any of this now, it's stupid. And sometimes it's dangerously stupid. We've seen it before, and we'll unfortunately see it soon. So with this positive note, I would like to thank you all.
Najlepša hvala. Zdaj pa jaz predlagam, da če ima kdo še kakšno vprašanje, da to naredimo nekako za mizo še. Midva pa imava samo še nalogo, da pravzaprav se zahvaliva. Oziroma najprej, da poveva, kaj so tista sporočila, ki želimo, da si jih danes vsi zapomnimo. Bom jaz začela s prvim predavanjem. Včasih smo rekli, papir prenese vse, kar pomeni, na papir se marsikaj lahko napiše, to, kar vidimo, je pa res. No, danes to več ne velja, tudi to, kar vidimo, je včasih neresnično oziroma moramo dvomiti. Bi ti lahko povedal, kaj si moramo zapomniti pri drugem predavanju? Umetna inteligencija, medicina?
Umjetna inteligencija je oruđe, alat, a liječnike ćemo trebati uvijek. Nažalost, bi neki rekli.
Odlično. Zdaj, kar pa je meni bilo všeč pri tvojem predavanju, pa me popravi, če pravzaprav nimam prav, znanosti ni treba verjeti, ne smemo pa je ignorirati.
Da.
Pravilno?
Da.
Odlično, potem pa najlepša hvala vsem predavateljem. Dr. Saša Ceci, en aplavz. Profesor Aleksandar Sadikov. Profesor Vitomir Štruc.
Ja bi samo za kraj rekao jednu stvar, evo ne mogu i na hrvatskom. Rekao sam vam da starog psa se ne može naučiti nove trikove, odnosno teško je. Ja ću vam reći kako se može naučiti starog psa nove trikove. Tako da starom psu kažeš da to zapravo učiš ovog mladog. Onda on sluša i kaže vidiš, dobro je.
Odlično, zdaj pa samo še ena velika zahvala vsem vam, ki ste danes prišli sem, ki ste recimo izrazili podporo našemu novemu projektu Skeptiki v pubu in jaz upam, da bo ta projekt rasel in da se še kdaj vidimo. Hvala vsem skupaj.